September 1944, captured German airfield, northwest France. Hauptmann Ernst Kessler stood at the edge of what had been Luftwaffe Station Évreux. Binoculars pressed against his face, watching something that violated every principle of engineering he understood. Across the cratered runway, American engineers had begun work 37 minutes ago. No concrete mixers, no heavy grading equipment, no surveying teams with instruments, just trucks unloading, flat metal panels, and teams of soldiers working in mechanical rhythm. His field notebook lay open on the hood of his staff car. He had already filled 3 pages with measurements, observations, and calculations. None of it made sense. Runway construction required weeks, foundation preparation, grading, drainage systems, concrete pouring, curing time. This was not construction. This was assembly. Kessler was a Luftwaffe engineering officer. Before the war, he had designed civilian airports in Hamburg and Munich. When the Reich needed airfields built across occupied Europe, they recalled him to service in 1940. He had overseen the construction of 42 military airfields from Norway to Greece. He understood runway engineering the way a surgeon understands anatomy. Every calculation, every specification, every constraint. A proper runway required months of work. The Évreux airfield had taken 7 months to build in 1941. Grading the land alone consumed 6 weeks. Laying the concrete base required another 8 weeks. The final surface took 4 weeks more. German engineers worked with precision. They built structures designed to last decades. They followed specifications that ensured perfection. But perfection required time, and time was something the Americans apparently didn't need. Through his binoculars, Kessler watched the 4th section of metal planking lock into place. Each panel was approximately 10 feet long, 15 inches wide, perforated steel, lightweight but rigid. The holes reduced weight while maintaining strength. Clever engineering. But the real innovation wasn't the panels themselves, it was the speed. 6 men per panel. They carried it from the truck. No machinery required. 260 pounds of steel distributed across 12 hands. They positioned it next to the previous panel. The edges had interlocking hooks, male connectors on one side, female receivers on the other. The panels clicked together like puzzle pieces. No welding, no bolting, no fasteners at all. Just mechanical interlock. One soldier used a sledgehammer, 3 strikes to seat the connection. Another soldier checked alignment with a simple straight edge. 5 seconds. The panel was locked. The team moved to the next panel. Kessler timed the sequence. 4 minutes per panel, from truck to final placement. He calculated the runway dimensions. The Americans were building a strip 12,000 feet long. Standard width for heavy bomber operations. 50 feet wide. For a single runway, 12,000 feet equals 120 panels lengthwise. 50 feet width equals 40 panels across. Total panels needed, 4,800. At 4 minutes per panel, sequential installation would require 320 hours, 13 days working continuously. But the Americans weren't working sequentially, they were working in parallel. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Kessler counted the teams. 24 teams worked simultaneously across the runway width. Each team handles 1 panel every 4 minutes. 24 panels every 4 minutes. 360 panels per hour. 4,800 panels divided by 360 equals 13 hours. But that assumed continuous work. Reality included material delivery, panel positioning, quality checks, rest periods, double the time for operational factors, 26 hours, add foundation preparation, even minimal preparation, 30 hours, add drainage considerations, 36 hours. The Americans would complete this runway in under 2 days. Impossible. Except he was watching it happen. Kessler had been stationed at Évreux until 5 days ago. The Allied advance forced German withdrawal. Standard procedure demanded airfield destruction before retreat. Luftwaffe engineers had executed demolition perfectly, explosive charges across the runway at 30-meter intervals. Detonation created massive craters. Each crater measured 6 meters across, 2 meters deep. The runway surface was shattered, concrete broken into rubble. The drainage systems were destroyed. Underground fuel lines were severed. The control tower was demolished. Hangars were burned. Every structure of military value was eliminated. German high command calculated the destruction would render Evreux unusable for at least 6 weeks. The Allies would need to clear rubble, fill craters, repair drainage, pour new concrete, and wait for curing. 6 weeks minimum. That timeline gave German forces time to establish new defensive positions 80 kilometers east, time to move supplies, time to regroup. But the Americans didn't repair the craters. They didn't fill them. They didn't pour concrete. They simply laid metal panels over the destroyed surface. The panels bridged the craters. Where the original runway had required perfect grading, perfect drainage, and perfect concrete work, the American system required only a reasonably flat surface. The perforated steel planking distributed load across enough surface area that minor irregularities became irrelevant. Kessler watched a supply truck drive across a section of newly laid runway. The truck weighed 4 tons loaded. It crossed without difficulty. No flexing, no settling. The panels held. Then came a weapons carrier. 6 tons. The runway absorbed the weight. Then a half-track, 9 tons of armored vehicle. The steel planking supported it without visible stress. Kessler understood the engineering principle. The perforation pattern wasn't just for weight reduction. The holes created a truss structure. Each panel became a horizontal truss beam. The strength-to-weight ratio was remarkable, but understanding the principle didn't change the fundamental reality. The Americans had solved a problem that German engineering had never seriously considered. Because German engineering approached problems differently, German engineers designed for permanence. They built airfields that would serve the Reich for generations. They used materials that would last decades. They followed specifications that ensured quality. The Americans had abandoned permanence entirely. They were designed for sufficiency. These runways didn't need to last decades. They needed to last months, maybe weeks, just long enough for the front to move forward and make the airfield obsolete anyway. This was the conceptual gap Kessler struggled to comprehend. German military doctrine treated infrastructure as permanent investment. Every airfield was a strategic asset built with long-term planning. American doctrine treated infrastructure as disposable logistics. Every airfield was a temporary tool built with immediate tactical needs in mind. The difference wasn't technical, it was philosophical. At 1100 hours, 3 hours into the operation, Kessler received a radio transmission. Luftwaffe intelligence wanted his assessment. They had reports of rapid American airfield construction across France. They needed technical evaluation. Could the reports be accurate? Kessler climbed into his staff car. He dictated his response while watching the American teams continue their mechanical rhythm. Luftwaffe intelligence. This is Hauptmann Kessler at the Evreux observation post, confirming reports of rapid American runway construction. The Americans are employing a prefabricated steel planking system. Panels interlock without fasteners. Installation rate approximately 360 panels per hour with 24 teams. Estimated completion time for full operational runway under 48 hours. The system requires minimal site preparation. Heavy bomber operations possible within 72 hours of initial work commencement. Silence on the radio. Then the intelligence officer's voice, careful and controlled. Hauptmann, please confirm. Did you say 48 hours for a complete runway? Confirmed. I'm observing the construction in real time. The system uses modular components, pre-manufactured panels, standardized dimensions, mechanical interlock connections. The Americans have eliminated traditional construction requirements entirely. What about load capacity? Can these temporary runways handle heavy aircraft? Kessler watched another truck cross the completed section. I have observed vehicles up to 9 tons crossing without visible stress, based on panel thickness and truss design, I estimate load capacity sufficient for B-17 and B-24 operations. The system is not temporary in the traditional sense. It is tactically permanent. Explain tactically permanent. The runway will not last decades, but it will last months. Long enough for strategic bombing operations, long enough to support tactical air superiority, long enough for the front to advance beyond this position and make the airfield irrelevant. The Americans are not building permanent infrastructure, they are building disposable logistics. More silence. And Kessler understood what the intelligence officer was thinking. The implications were devastating. Every destroyed Luftwaffe airfield in France could be restored to operational status within days. Every crater, the Wehrmacht engineers so carefully placed, was merely a temporary inconvenience. The entire defensive strategy, based on infrastructure destruction, was obsolete. Hauptmann, prepare a detailed technical report, dimensions, materials, construction sequence, load testing observations, timeline analysis. Wehrmacht High Command will need complete documentation. Understood. The report will be transmitted in 1800 hours. Kessler hung up the radio handset. He returned to his binoculars and notebook. The Americans continued working with mechanical efficiency. No wasted motion, no confusion, no delays. They had done this before, many times. The movements were automatic. Load panel, position panel, connect panel, check panel, move to the next panel. He calculated training requirements. To install one panel correctly required perhaps 2 hours of instruction. To become proficient requires repetition. 100 panels, 200 panels. After 500 panels, the procedure became muscle memory. The American Engineer Corps had installed tens of thousands of panels across the Pacific, North Africa, Italy, and now France. They were experts in this one specific task. Germany had an engineering corps trained in comprehensive construction. They could build anything from field fortifications to permanent airfields. But comprehensive training took time. Specialized training took weeks. The Americans had chosen specialization. Train thousands of soldiers in one specific system. Make them experts in rapid runway deployment, except that they couldn't build traditional infrastructure, except that they didn't need to. At 1300 hours, 5 hours into construction, Kessler noticed something new. The Americans were installing additional equipment, lighting systems, portable lights on steel stands. They positioned lights every 100 feet along both runway edges. The electrical cables connected to portable generators. The generators ran on gasoline. Everything was mobile. Everything was standardized. Night operations. The Americans were preparing for 24-hour flight operations. They weren't just building a runway. They were building a complete tactical airbase in 3 days. Kessler watched the fuel trucks arrive. They carried aviation gasoline in portable tanks, 5,000-gallon capacity per truck. The trucks parked in dispersed positions away from the runway. Fuel distribution would be by vehicle, not pipeline. Less efficient than permanent underground fuel systems, but operational within hours instead of weeks. Then came the ammunition trucks. They unloaded bombs, machine gun belts, cannon shells, everything needed for bomber and fighter operations. The supplies were stored in temporary revetments, earthen berms bulldozed into protective walls, crude but functional, built in hours, sufficient for tactical needs. Kessler understood what he was witnessing. The Americans weren't trying to match German engineering quality. They were creating an entirely different paradigm. German airfields were engineering marvels, beautiful, permanent installations with underground fuel systems, reinforced hangars, proper drainage, and concrete runways designed to serve for decades. American airfields were industrial products, mass-produced, rapidly deployed, tactically sufficient, and completely disposable. When the front moved forward, the Americans would abandon this airfield and build another one 100 kilometers east. They would do it again and again across France, into Germany, until they reached Berlin itself, and Germany couldn't stop them, because Germany couldn't build faster than America could destroy and rebuild. The industrial capacity gap was unbridgeable. Kessler pulled out his production estimates. The steel planking system required massive manufacturing capacity. Each panel needed precision fabrication. The perforation pattern required specialized dies. The interlocking edges required exact tolerances. Quality control needed to ensure interchangeability. One runway required approximately 5,000 panels. The Americans were advancing across France on a front 400 kilometers wide. They needed airfields every 100 kilometers for tactical air support. 4 airfields per advance, 20,000 panels. If the Americans advanced 100 kilometers per month, they needed 20,000 new panels per month, just for the French campaign. But the Americans were also fighting in Italy and supporting operations in the Pacific and building training airfields in England and the United States. Total panel production probably exceeded 100,000 per month. 100,000 precision fabricated steel panels every month, while also producing tanks, aircraft, ships, trucks, weapons, ammunition, uniforms, rations, medical supplies, and everything else needed to wage global war. Germany's steel production in 1944 was approximately 8 million tons annually. America's steel production exceeded 90 million tons. The Americans produced more steel in 1 month than Germany produced in an entire year, and the Americans were using that excess capacity for everything, not just weapons, but logistics, infrastructure, support systems, the Marston Mat. That's what Kessler had heard American soldiers call the steel planking, named after the town in North Carolina where it was first tested. Marston Mat represented American industrial philosophy: identify a problem, engineer a solution, manufacture at scale, deploy globally. Replace as needed, no consideration of permanence, no pride in artistic engineering, just brutal industrial efficiency. Kessler thought about his airfields: Hamburg, Munich, beautiful installations with Art Deco control towers and landscaped approaches, runways smooth as glass, drainage systems that could handle the worst storms, hangars large enough for Zeppelin operations, built to represent the power and sophistication of the Reich, built to last centuries. How long had Hamburg's civilian airport taken to build? 4 years, from initial planning to operational status. 4 years of careful engineering, 4 years of quality construction, and the Hamburg airport could be destroyed in 1 day by strategic bombing and rendered permanently unusable. The Americans could build a replacement airfield in 3 days. Crude, ugly, functional, disposable. This was how empires fell, not through lack of courage, not through tactical defeat, through industrial obsolescence, through the discovery that your carefully crafted excellence had become irrelevant in the face of mass-produced adequacy. The Americans didn't need better airfields. They needed more airfields, and they had solved that problem completely. At 1800 hours, Kessler transmitted his detailed report to Wehrmacht High Command. Panel dimensions, connection mechanisms, installation procedures, load testing observations, timeline calculations, material estimates, training requirements, every technical detail he could document. The report was factual, precise, devastating. He concluded with his strategic assessment. The American rapid runway system represents a fundamental change in airfield construction doctrine. A traditional destruction of enemy airfields no longer provides meaningful delay to enemy operations. Current Wehrmacht calculations assume 6 weeks for enemy airfield restoration. Actual restoration time under 72 hours. Recommend immediate revision of defensive strategy. Focus should shift from infrastructure destruction to sustained interdiction of construction operations and deployed air assets. Kessler knew the report would be read, analyzed, discussed, filed, and ultimately ignored, because accepting the report's implications meant accepting that Germany's defensive strategy was obsolete, that the careful demolitions were pointless, that the time bought by destroying infrastructure was measured in days, not weeks, that the war was unwinnable through attrition. The German High Command would not accept that conclusion. They would find reasons to doubt the report. Perhaps the Americans had special conditions at Évreux. Perhaps this was experimental. Perhaps operational difficulties would emerge later. Perhaps load capacity would prove insufficient. Perhaps maintenance requirements would create delays. There were always reasons to maintain certainty in the face of contradictory evidence. At 2200 hours, as twilight settled over the former Luftwaffe station, Kessler watched the portable lights illuminate. The American work continued, the mechanical rhythm unchanged, panel after panel, section after section. The runway grows longer with each passing hour. By midnight, the Americans had completed 60% of the runway. By dawn, they would finish the primary surface. By noon the next day, they would complete the taxiways and dispersal areas. 72 hours from initial work to the operational airbase. Everything the Americans needed to dominate the tactical airspace over France, and there was nothing Germany could do to prevent it. Kessler climbed into his staff car. His driver started the engine. They drove east through the darkness, away from the growing American airfield toward the shrinking German defensive lines. Behind them, the portable lights glowed like a constellation of industrial efficiency. September 20th, 1944, 24 hours since the American engineers began work at Évreux, and Kessler returned to his observation position at dawn. The runway was complete, all 12,000 feet. The Americans were conducting final inspections. Teams walked the entire length, checking panel connections, examining any irregularities, marking areas for attention. At 0700 hours, the first aircraft arrived, a P-47 Thunderbolt single-engine fighter. The pilot made a low pass over the runway. Reconnaissance, checking surface conditions, visual inspection before commitment. The Thunderbolt climbed, circled, and lined up for approach. Kessler watched through his binoculars. The aircraft touched down, wheels on steel planking. The landing was smooth. No visible bouncing, no unusual sounds. The P-47 rolled to the end of the runway, turned and taxied back. The pilot didn't report problems. More aircraft appeared, a formation of 3 P-47s. They landed in sequence, 30 seconds apart, professional approach, standard spacing. The runway handled all three without difficulty. Then came the bombers, B-26s, medium bombers, twin-engine aircraft, 23 tons, fully loaded. The first Marauder approached. Kessler held his breath. A bomber landing on a runway, installed in 24 hours. The wheels touched. The bomber's weight compressed the steel planking, but the runway held. No flexing, no failure. The bomber decelerated and turned off onto the taxiway. The second bomber followed, then the third. 6 bombers landed within 10 minutes, all successful, all without incident. The Americans had their operational airbase, 72 hours, ahead of any timeline German intelligence had calculated. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Kessler remained at his observation post for another 48 hours. He watched continuous operations, fighters taking off on combat patrols, bombers departing for tactical strikes against German positions, supply aircraft delivering equipment and personnel. The Americans had transformed a destroyed Luftwaffe installation into a fully operational Allied airbase in exactly 72 hours. He documented everything: sortie rates, aircraft types, maintenance procedures, refueling operations, the logistical rhythm of American tactical air power. What he observed challenged every assumption about operational tempo and sustainability that German doctrine had established. The Americans launched sorties every 30 minutes during daylight hours, continuous operations, wave after wave of fighters and bombers. German airfields operating from concrete runways in Germany itself couldn't match this tempo. Fuel shortages limited operations. Pilot shortages reduced sortie rates. Maintenance difficulties grounded aircraft. But the Americans, operating from a runway installed 3 days ago on French soil, maintained operational intensity that exceeded Germany's best capabilities. Kessler calculated fuel consumption. Each B-26 required approximately 900 gallons of aviation gasoline for a tactical mission. 6 bombers meant 5,400 gallons per mission. The Americans launched bomber missions 4 times daily. 21,600 gallons of fuel consumed daily, just for bomber operations. Add fighter operations, add transport flights, add ground vehicle fuel requirements. Total fuel consumption exceeded 30,000 gallons daily. The American supply trucks delivered fuel continuously, an endless convoy from supply depots established behind the front lines. The fuel came from somewhere. It was manufactured somewhere. It was transported across the Atlantic. It moved through French ports. It flowed forward to tactical airfields like blood through arteries. The logistics were invisible, but absolutely essential. Without fuel, the steel runway was meaningless. Without ammunition, the aircraft were worthless. Without spare parts, maintenance was impossible. But the Americans had all of it: fuel, ammunition, spare parts, replacement aircraft, replacement pilots, everything needed to sustain operations indefinitely. Kessler thought about Luftwaffe logistics. German fuel production had collapsed under strategic bombing. Synthetic fuel plants in the Ruhr were destroyed faster than they could be rebuilt. Aviation gasoline was rationed. Pilots couldn't train adequately because fuel for training flights wasn't available. Combat units received priority allocation, but even combat units operated under restrictions. Sorties were limited. Missions were carefully planned to avoid wasting fuel. Replacement aircraft arrived slowly because factories were bombed. Replacement pilots arrived inadequately trained because fuel for training was scarce. The entire system was collapsing under the weight of industrial attrition. The Americans suffered no such constraints. They had fuel abundance. They flew training missions for hundreds of hours before pilots entered combat. They could afford to use aircraft for supply delivery. They could afford to maintain multiple aircraft as operational reserves. They had surplus capacity in everything. This was the fundamental difference. Not tactics, not courage, not technology. Surplus industrial capacity. At 1400 hours on September 21st, Kessler observed something that crystallized his understanding. A damaged B-26 returned from a mission. The bomber had taken flak damage over a German position. The right engine was smoking, the landing gear partially deployed. The pilot made an emergency landing on the steel planking runway. The touchdown was rough. The bomber skidded slightly, but the runway held. American maintenance crews swarmed the aircraft within minutes. They assessed the damage, engine replacement required, landing gear repair needed, airframe inspection necessary, total repair time estimated at 48 hours. But the Americans didn't repair the aircraft on site. They simply pushed it off the runway into a dispersal area. Within 30 minutes, another B-26 arrived from a rear airbase, a replacement aircraft, undamaged, fully operational, ready for immediate combat tasking. The damaged bomber would be repaired eventually, or it would be cannibalized for parts, or it would be written off entirely. The decision would be made based on efficiency calculations, but the tactical situation was unaffected. One aircraft was damaged, one aircraft was replaced, operational capacity maintained. Germany couldn't do this. A damaged Luftwaffe bomber would be carefully repaired because replacement aircraft were scarce. Skilled mechanics would work for days to restore operational status. Every aircraft was precious. Every piece of equipment was irreplaceable. The Americans treated aircraft as industrial products, damaged beyond efficient repair. Replace it. Need spare parts. Cannibalize written-off aircraft. Operational requirements increase. Manufacture more aircraft. The industrial base could support any operational demand. Kessler calculated American aircraft production. Intelligence estimates suggested the United States manufactured approximately 8,000 aircraft per month. 8,000. Germany's total production was approximately 3,000 aircraft per month and declining under strategic bombing pressure. The Americans produced nearly 3 times as many aircraft as Germany, and American production was increasing. New factories, expanded capacity, more workers, better efficiency. German production was collapsing. factories destroyed, workers killed, raw materials are scarce, transportation disrupted. The gap widened every month. By 1945, the Americans would produce 100,000 aircraft annually. Germany would produce perhaps 20,000 if current trends continued. 100,000 versus 20,000. 5-to-1 advantage. But numbers alone didn't capture the full picture. American aircraft were supported by surplus logistics. German aircraft were supported by failing logistics. An American fighter with adequate fuel, trained pilots, and maintenance support was worth 10 times a German fighter without these essentials. The mathematical advantage became overwhelming when multiplied by logistical superiority. Kessler thought about the Marston Mat runway. It was more than engineering innovation. It was the physical manifestation of American industrial philosophy. Build it fast, build it cheap, build enough of it that losses don't matter, replace it when necessary, move forward continuously, never stop, never slow down, maintain momentum through sheer industrial output. Germany's philosophy had been different. Build it perfectly, build it to last, build it as a symbol of national excellence, maintain it carefully, preserve it when possible. This philosophy worked when Germany held the initiative, when Germany was advancing, when time was available. But in 1944, Germany was retreating. Time was the enemy. Perfection was a luxury. And symbols of national excellence were becoming monuments to industrial obsolescence. At 1800 hours, Kessler received new orders. Wehrmacht High Command wanted him to observe American airfield construction at multiple sites. Intelligence needed comparative data. Were the Évreux observations typical or exceptional? Kessler traveled across northern France over the next 2 weeks. He observed American airfield construction at 7 different locations. Every site showed identical procedures, same steel planking, same installation methods, same timeline, same results. At Chartres, the Americans completed a 10,000-foot runway in 60 hours. At Reims, they built a dual runway system in 96 hours. At Laon, they constructed a complete airbase, including maintenance facilities, fuel storage, and ammunition dumps, in 120 hours. The pattern was consistent. The system was proven. The Americans had solved tactical airfield construction completely. Kessler compiled his observations into a comprehensive technical report, 37 pages, detailed specifications, construction sequences, timeline analysis, logistical requirements, strategic implications. He submitted the report to Wehrmacht High Command on October 5, 1944. The report concluded with a strategic assessment that he knew would be unwelcome, but was absolutely necessary. The American rapid runway construction capability fundamentally alters the strategic calculation for airfield defense and destruction. Traditional doctrine assumes that destroyed infrastructure provides time for defensive redeployment. This assumption is no longer valid. The enemy can restore airfield capacity within 72 hours of initial occupation. This capability provides the following advantages. First, tactical air superiority can be maintained continuously during rapid advances. Second, supply delivery by air transport becomes viable even in fluid battlefield situations. Third, strategic bombing operations can be staged from forward positions, reducing flight times and increasing sortie rates. He continued. German defensive strategy currently emphasizes infrastructure destruction as a delaying mechanism. This strategy is obsolete. Destroying an airfield delays American operations by 3 days maximum. The resources required for effective destruction, explosives, engineering personnel, and time exceed the strategic value gained. Recommendation: abandon infrastructure destruction as primary defensive strategy. Redirect resources to mobile defense and preservation of combat forces. Accept that the enemy will have operational airfields wherever desired. Focus defensive efforts on degrading enemy operational capacity, not enemy infrastructure. The report was classified and distributed to senior Wehrmacht commanders. Kessler never received direct feedback, but intelligence officers told him later that the report caused significant debate at high levels. Some commanders accepted the analysis, others rejected it as defeatist. The fundamental problem was that accepting Kessler's conclusions meant accepting that Germany's defensive strategy was failing, that the careful demolitions were pointless, that the war was being lost through industrial attrition rather than tactical defeat. German military culture struggled with this reality. The Wehrmacht had been trained to believe in tactical excellence. German officers studied Clausewitz. They understood maneuver warfare. They appreciated bold offensive action. They believed that superior tactics could overcome material disadvantage. This belief had been validated in the early war years. Germany had defeated Poland, France, and launched Operation Barbarossa, with tactical brilliance overcoming numerical disadvantage. But by 1944, the math had changed. Tactical excellence couldn't overcome 10-to-1 material disadvantage. Superior training couldn't compensate for lack of fuel. Brilliant maneuver was impossible when the enemy controlled the airspace absolutely. The Americans didn't need tactical brilliance. They needed adequate competence multiplied by overwhelming material superiority. And they had it. Kessler thought about the German engineers who had built Evero Airfield in 1941. They had worked for 7 months. They had graded the land perfectly. They had installed comprehensive drainage systems. They had poured concrete runways, smooth as glass. They had built reinforced hangars. They had created underground fuel storage. They had designed the installation to serve the Luftwaffe for decades. It was beautiful work. Professional engineering, a credit to German technical excellence. The Americans had replaced it with steel panels in 72 hours, and the American version worked just as well for tactical purposes. It wasn't beautiful. It wasn't permanent. It wasn't a symbol of anything except industrial efficiency. But it was sufficient. And sufficient was all that mattered in modern war. This was the lesson Kessler learned watching the Marston Mat runway grow across the cratered remains of Evero Airfield. Excellence was expensive. Sufficiency was cheap. And in industrial warfare, cheap sufficiency available in vast quantities defeated expensive excellence available in small quantities. The strategic bombing campaign demonstrated this principle repeatedly. German fighters were technologically superior to American bombers. The Focke-Wulf 190 and Messerschmitt 109 could shoot down B-17s and B-24s consistently in one-on-one engagements. But the Americans didn't send bombers in ones. They sent them in hundreds, surrounded by hundreds of escort fighters, supported by electronic warfare, covered by tactical deception. One German fighter might shoot down 3 American bombers before being destroyed. But if the Americans sent 500 bombers and lost 50, they still delivered 450 bombing runs. The mission succeeded. The factory was destroyed, and the Americans manufactured replacement bombers faster than Germany could shoot them down. The mathematics were brutal. The outcome was inevitable. November 1944. Kessler received orders to report to Berlin. Wehrmacht High Command wanted him to brief senior staff on American rapid construction capabilities. He traveled through Germany by rail. The journey took 3 days. It should have taken 18 hours. But the railway system was collapsing. Strategic bombing had destroyed marshalling yards, bridges, and rail lines. Trains were delayed for hours awaiting track repairs. Detours added hundreds of kilometers. The industrial backbone of Germany was disintegrating. In Berlin, Kessler presented his findings to a room full of Wehrmacht generals and Luftwaffe officers. He showed photographs. He presented timeline data. He explained the Marston Mat system in technical detail. He described the American logistical infrastructure. He concluded with his strategic assessment. The room was silent when he finished. Then came the questions. Most were technical, some were skeptical, a few were hostile. One general asked if the American runways could handle winter conditions. Kessler explained that the perforated steel allowed drainage and prevented ice accumulation better than solid concrete. Another asked about maintenance requirements. Kessler noted that damaged panels could be replaced individually within hours. No need to repair concrete. Just swap out damaged sections. A Luftwaffe officer asked if concentrated bombing could destroy the steel runways. Kessler acknowledged that sufficient bombing could crater the runway. But the Americans would repair it within 24 hours. The steel panels could bridge craters. Where concrete required complete reconstruction, steel required only panel replacement. The officer pressed. "What if we bomb continuously?" Kessler responded carefully. "Sir, continuous bombing requires continuous availability of aircraft, fuel, and munitions. Our current operational capacity does not support sustained bombing of tactical airfields while also defending against Allied strategic bombing of German infrastructure." The room went quiet. Everyone understood the implication. Germany lacked the resources to interdict American airfield operations effectively. The strategic initiative belonged entirely to the Allies. Another general asked about German development of similar systems. Could Germany copy the American design? Kessler explained the manufacturing requirements. Precision steel fabrication, specialized dies for perforation patterns, quality control for interchangeability, mass production of thousands of panels per month. The general interrupted. Yes, but can we do it?" Kessler chose his words carefully. "Sir, the engineering is straightforward. Any competent industrial facility could manufacture these panels. The constraint is not technical knowledge. The constraint is industrial capacity. The American Marston Mat program requires dedicated steel allocation, dedicated manufacturing facilities, and dedicated logistics for distribution. Germany's steel production is currently allocated to weapons manufacturing, ammunition production, and essential infrastructure repair. Diverting resources to a rapid runway program would reduce weapons production proportionally." He paused, then continued. "Furthermore, Germany's tactical situation differs from America's. The Americans are advancing. They need to build airfields in newly captured territory. Germany is defending. Our existing airfields have concrete runways. We need to preserve and defend existing infrastructure, not build new infrastructure in enemy territory." This was diplomatic phrasing. For a harsh truth, Germany couldn't build Marston Mat runways because Germany was losing. The industrial capacity for such programs required surplus resources. Germany had no surplus. Every ton of steel went directly to weapons. Every factory operated at maximum capacity, producing essential war materials. There was nothing left over for innovation or alternative systems. The briefing concluded with polite thanks. Kessler was dismissed. He never learned if his assessment influenced strategic planning. He suspected it didn't. By November 1944, German strategy was reactive. Respond to Allied advances. Plug gaps in defensive lines. Delay the inevitable. There was no capacity for proactive strategic adjustment. Kessler returned to his engineering unit. He continued observing American operations. He continued writing reports. He continued documenting the systematic industrial destruction of German defensive capabilities. By January 1945, the Americans had built over 60 tactical airfields across France and Belgium. 60 airfields, each supporting continuous bomber and fighter operations, each supplied with fuel, ammunition, and spare parts, each operational within days of German withdrawal from the territory. The Luftwaffe couldn't contest this airspace. German fighters flew occasional sorties when fuel was available. They achieved local tactical successes. They shot down enemy aircraft. They disrupted some bombing runs. But they couldn't change the strategic picture. The Americans owned the air. They flew when they wanted. They bombed what they wanted. They supported ground forces without restriction. Kessler watched the German retreat accelerate. The Rhine defenses collapsed. The Ruhr industrial region fell. Berlin came under siege. Throughout this collapse, he continued to see evidence of American industrial superiority, not just in the air, everywhere. American trucks filled with supplies, American tanks advancing in formations that German forces couldn't match. American artillery fired more shells in one day than German forces fired in a week. The steel runway at Évreux had been his first clear view of this reality, but it was everywhere, once you knew to look. The Americans had surplus capacity in everything. They could afford to build disposable infrastructure. They could afford to replace damaged equipment. They could afford to experiment with new systems. They could afford to fail and try again. Germany could afford none of this. Germany was operating on the edge of industrial collapse. Every resource was precious. Every decision was critical. Every loss was irreplaceable. May 1945. Germany surrendered. Kessler survived the war. After the fall of Berlin, he was interviewed by American military intelligence officers. They asked about his observations of American operations. They asked about German defensive strategies. They asked about his reports to Wehrmacht High Command. One American officer asked specifically about the airfield construction report. Did the German command change strategy based on your assessment? Kessler considered the question. No, the report was received, it was discussed, but the fundamental strategy didn't change. German defensive doctrine was built around infrastructure destruction as a delaying mechanism. Changing that doctrine would require accepting that the war was lost. The German command wasn't prepared to accept that conclusion in October 1944. The American officer nodded. We read captured copies of your report. It was technically accurate. Your timeline estimates matched our actual construction data. Your strategic assessment was correct. Did you realize at the time that the war was effectively over? Kessler thought back to that September morning at Évreux, watching the steel panels lock into place, calculating the impossible timeline, understanding what it meant. Yes, he said finally. I realized when I watched your engineers build a runway in 72 hours that Germany had lost the industrial war. We might win tactical battles. We might delay advances, but we couldn't match American productive capacity. Once I understood that your military could build infrastructure faster than we could destroy it, I understood the war was lost. The American officer made notes, then asked, why do you think German command didn't accept your assessment? Kessler had thought about this question for months. Because accepting the assessment required accepting defeat, and professional soldiers are trained never to accept defeat while combat capability remains. German forces could still fight, therefore the war could theoretically still be won. The mathematics said otherwise, but military culture doesn't operate on mathematics alone. The Marston Mat runway system remains one of the most successful engineering innovations of World War II. Over 1 million tons of perforated steel planking was manufactured between 1941 and 1945. The system was deployed globally. North Africa, Pacific Islands, Europe, Asia, anywhere American forces needed rapid airfield construction. The panels were so successful that many remained in use for decades after the war. Civilian airports in developing nations used surplus Marston Mat. Remote airstrips used it. Even today, some of the original World War II panels remain in service in various locations worldwide. But the deeper significance of the Marston Mat system extended beyond its technical specifications or operational longevity. It represented a fundamental shift in how modern warfare approached the relationship between permanence and utility. Traditional military infrastructure was built to last: fortifications, roads, bridges, airfields, all designed with long-term service in mind. The Romans built roads that lasted centuries. The great fortifications of Europe served for generations. The Marston Mat represented the opposite philosophy: build for immediate need, accept that permanence is unnecessary, optimize for speed and replicability, accept that today's infrastructure will be obsolete tomorrow when the front moves forward. This philosophy only worked with massive industrial capacity. You could only treat infrastructure as disposable if you had the capacity to build more infrastructure continuously. You could only accept obsolescence if you had the resources to replace what became obsolete. Germany lacked this capacity. Germany had to preserve infrastructure because replacing it was difficult. Every bridge destroyed was a strategic loss. Every airfield captured was a permanent defeat. German strategy tried to deny infrastructure to the enemy because Germany couldn't imagine infrastructure as disposable. The Americans could imagine it. More importantly, they could implement it. They had the steel, they had factories, they had the workers, they had the logistics, they had the surplus capacity to build, abandon, and build again without strain. This was the true lesson of the 72-hour runway. Not that American engineering was superior. German engineers could have designed similar systems, but that American industrial capacity made disposable infrastructure viable, and once infrastructure became disposable, traditional defensive strategies based on infrastructure destruction became obsolete. The war wasn't decided by tactical excellence or strategic brilliance. It was decided by industrial output. The side that could produce more steel, more fuel, more aircraft, more everything, would eventually win through sheer material accumulation. Kessler understood this, watching the Marston Mat panels lock into place across the ruins of Évreux airfield. He understood that Germany was fighting a type of war that German military tradition had never contemplated: industrial war, where victory came not from brilliant generals or brave soldiers, but from factories and production lines and logistics networks, where the decisive battles weren't fought on battlefields, but in steel mills and aircraft factories and shipyards. Germany had prepared to fight a war of maneuver and tactical excellence. America fought a war of production and logistics, and production won. The steel runway at Évreux was just one small example of this larger reality, but it was the example that made Kessler realize the war was already lost, not because German forces couldn't fight, but because German industry couldn't compete. The mathematics were simple. The outcome was inevitable. It was just a matter of time. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.